Hello everyone, I'm Kowshiq Kattamuri. Welcome to this new video. So this is our second video in the course Introduction to DS using C++. So this video will explicitly be on the problems. So I have taken nearly 15 problems. I'll walk you through the document, not to worry. So there are 15 problems that we'll be discussing now. So we'll be using the platform lead code that is to our left. So to all those who are not familiar with what is lead code, I would recommend you to check it once, Google it. You'll like know a lot of things about it. Like lead code is a coding platform where you will find lot of questions, and this is my profile there. So I had a very good experience in lead code, using lead code. So there's not just lead code, there's even geeks for geeks, and there's even code forces, code chef, at coder, like lot of things are there. Fine. So we'll be solving the questions here. So before that, I would like to let you people know, like there are two documents here, and one is this C++, sorry, this one is this C++ STL problems for revision, and second one is C++ STL assignment. All right. So these are the problems that we're gonna do. Like I've already uploaded these two in the like our dashboard. Like you can see them over there. Like in our course dashboard, you can see these two files. So and like these are the two files that we'll see in great detail. So here we have a lot of problems, like nearly 15 problems, and for each problem I have attested the link. On clicking it, you'll be redirected to lead code, and they have even mentioned what is the STL that's being used to solve that. All right. So because I've got feedback from you people that you want more examples to be taught, and STL is not a very great topic to deal a lot of questions and spend a lot of time, because many of us are in the time constraint. So that was the reason I avoided a lot of examples. But because I've got the feedback, I thought of making a separate video just for the case of examples. All right, so these are the 15 examples that we're gonna see now, and I've covered almost every main HTL, like starting from vector and string and stack, priority queue, unordered set, multi-set, map, unordered map, multi-map, and basic math thing like Nux permutation. I feel it's somewhat an important STL that you people need to know. And this is all. So we'll be looking at all these problems. So as I've already uploaded the PDF, what I would recommend to you people is go to this link of the each and every question. Go to the link of each and every question. Okay. So start with the very first problem. Spend some time. Spend 5 to 10 minutes. Try solving it. If you are not able to solve it, come to the video that that will be uploaded. Right. Like after 2 3 hours of this recording stuff is done. So you can watch this video if you are not comfortable in solving it, and then again come to second question, try solving it, and then watch the solution. Okay, so don't watch the video just like that. So try the problems and then watch the video, so that it will be like hands-on experience on these things before actually watching the whole solution. So I would recommend this to you people. And so yeah, there are very good number of problems, to be honest. Like with this, I hope you people will get enough clarity of how do we use STL, like how beneficial it is to us. Okay, and coming to the assignment, so these are some 9 points that you need to know before you look at the assignment. So there are total of three questions. The first two are compulsory. Like the first question, this is the first question, this is the second question, and this third question, this is optional. It's up to you people, like whether you solve it or not. Like there'll be no grading for the third question. There is no need to write the complete code for any of the question below. So once we start solving in the lead code platform, you'll understand like what I'm actually trying to say. So here you can see you need not write the whole code, just write the code to the function below. So there is some function int h index, and to that function we are passing the parameter, the input as references array. You must use this and write the code, write this, try to solve it, and then return an integer value. All right, because this function returns an integer value. We have int here, right? We have int here. So you must understand, you must be able to understand by now that you must write some code which takes the input of references vector, which uses this and returns some integer value. Same is the case here. Like here it returns a vector, and in the third question it returns an int. Okay, again I'm mentioning that it is optional. Third question you need not solve it if you are not interested to. And so just write the code for the function mentioned in each question. So write the required codes for all of the questions in a single MS Word or Google Docs file and upload the PDF version of it to Moodle. So in the Moodle, you'll be able to see an option to upload your files. It starts from tomorrow. It starts accepting the files from tomorrow. So you can just write the whole code in a single file. Write question number one solution and write the code. Question number two solution, write the code, and question number three solution and write the code. Make sure the code you'll be submitting is successfully running on any of the online compilers with your own input. All right. So try to go to GDB online compiler or VS Code compilers if you have. Okay. Write the whole code on your own. Like that is when that is how you can take the input, right? So after you take the input, try running it, because many of the cases we miss to put a semicolon or miss to put a flower bracket at the end. So all those things may look simple, but I cannot be evaluating if something misses out. Like if it doesn't successfully run in the program while I'm evaluating your answers, then I cannot award any marks to it. So that is the reason I'm asking you people to check beforehand and then submit. Do not worry about the constants on the input. All right, this is a very very important point. Don't worry about the time complexity stuff or something like that. Write the most optimal code possible. Okay, write the most optimal code. Try to figure it out, which includes the STL at least. Okay, so STL that we have learned so far, that will be more than enough to solve these questions, to be honest. And that's my promise also. All right, so you need not think out of the box. You just need to use some sort of logic and the STL that we have learned so far. That is more than enough to solve these two questions. All right. So, and code submitted will be evaluated on a particular number of test cases for every question. And depending upon the accuracy, what is accuracy? Number of test cases passed divided by number of test cases allotted for that particular question, the scoring will be done. For example, let us assume there are 100 test cases for the first question. And if your code has passed 70 test cases out of 100, so 70 by 100 into the score, like the maximum score that can be awarded for each question is 10 points. So this is like, you can just evaluate it. This turns out to be 7 points. All right, so I'll be awarding 7 points to that particular question. So this is how the evaluation will be done, and I've even given the deadline to be 10 June 2023. That is 7 days, like a week, to solve just two questions. And every source that need is required to solve these two questions have been given in terms of both video and documents. Refer to the STL document that I've sent earlier. That is more than enough if you have gone through each and every STL that's there. And it just it will not take more than 2-3 hours, to be honest, to complete the whole STL, referring to the whole STL document that I've sent. And that is more than enough to solve these two questions easily. These can be solved very easily. You might face some difficulty in understanding the question. If there are any such things, just feel free to DM me on WhatsApp. I'll definitely be happy to help you on this. All right. So this is the assignment. So I think have given enough clarity on all this, like both these concepts. And yeah, so let us start solving now. And yeah, so let us first copy this first link, and I'll be opening this in my Chrome rather than this Explorer stuff. Copy link. All right. So it takes some time to load. Yeah. So here is our first question, and remember, we'll be solving all these things with the STL that we have learned. Not anything that will be using will be out of this codes that we have covered so far. So all of the things that we'll be discussing, we'll be solving it explicitly using the STL that we have learned so far. That is for sure. So let us first understand the question. I've even taken my notes to the left, to the right. So I'll annotate the stuff that is there to explain you people. So there are n kits with candies. You are given an integer array candies where each candies of I represents the number of candies the ith kid has, and an integer extra candies denoting the number of extra candies that you have. I hope we have got some enough clarity. So there is some sort of candies array. So the first kid has two candies with him. The second kid has three candies with him. The third kid has five candies with him. The fourth kid has one candy with him. The fifth kid has three candies with him. And the extra candies that we have are three. Like these three are with not with them, it's with us. Return a boolean array result of length n where result of I is true if after giving the ith kid all the extra candies they have will have the greatest number of candies among all the kids, or other false otherwise. Note that multiple kids can have the greatest number of candies. So what the question says is, now let us assume I'm giving this three candies. So let us write this over here. So the first kid has two, second kid has three, third kid has five, the fourth kid has one, and fifth kid has three. And the extra candies that I have is three. Now let us assume I give this three candies to the first kid. So the number of candies that he has now would be five. And this five, like he is asking that if after giving the ith kid all the extra candies, they'll have the greatest number of candies among all the other kids. So when I give three to him, the number of candies that he's gonna have is five. So five is greater than three. Five is greater than, like, it is equal to five. Five is greater than one. Five is greater than three. So it's like he has the number of candies to be much more than almost all the other kids, right? So except with one kid, he has the candies to be more in number than the other three and equal to the fourth member. So in this case, we can put true to his index. All right, true to his index. Come to the second kid, you can give three to him, and this guy will be having six right now. So six is greater than two, six is greater than five, six is greater than one, six is greater than three. So we'll have true to him. When we give 3 to 5, we'll have 8 candies, and 8 is greater than 2, 8 is greater than 3, 8 is greater than 1, 8 is greater than 3. So we'll have true to even him as well. All right. So when we give 3 to him, we'll have 4, right? We'll have 4. So 4 is not greater than 5. So there is one kid who is leading him, even after giving him 3 candies. So we'll be putting false to him. All right. And to the last kid, 3 plus 3 6. Again, it is much more greater than all the other kids. So we'll be putting true here. So this is how the logic is. All right. So we just need to add 3 to each and every component and check if we are crossing it or not. Like if it is the maximum element possible in the vector or not. All right. So I hope you people got enough clarity about the question. Let me zoom this out a bit, and I'll even zoom this. Then I hope you people will get to see it better. Okay, so yeah, this is fine, I guess. So now I hope you understand I hope you understood the logic. So let us solve this right now. So we need to return a result array, which is a type of bool. So we'll write it vector bool result, and before that we'll see the size of the candies array. Int n is equal to candies dot size. All right. So candies dot size. What does dot size give? Dot size gives the size of the vector. Size of the vector. So we'll be getting the candy size, like candy's vector size by dot size, and vector bool result. And here we'll be having n, and let us assume all of them to be false. All right, and false. So like this is how one way of declaring a vector. I hope you went through the article for the vectors, and this is how we can declare the size and putting all of them to be false. Now let us iterate through each and every element and check. So for int I is equal to 0, I less than n, I plus plus, if candies of I plus extra candies. All right. So after giving extra candies to the candies of I, so to the amount of candies that are present to the at the ith kid, if this is greater, all right, this is greater than or equal to star max element of candies dot begin, candies dot end. All right, then we'll have that particular kid's result to be, all right. So what did we actually do? So candies of I plus extra candies is greater than or equal to star max element. So what does star max element do? Star max element points to the address, points to the address of the maximum element, the maximum element present in the vector. All right, present in the vector, present in the vector. So maximum element candice begin, candice dot end. So what does this do? What is the maximum element that is present over here? It is 5, right? It is 5. This is where the max element will point out, and when you put a star to it, it will get the value that is there at that address. So star will actually point to that value. So max element, when you do it, you'll be the max element will be pointing to this address. When you put a star, you'll be able to get that value that is there at that address. So the 5 is what the star max element is. And now when you add 3 to 2, that is greater than or equal to 5, so we can put at that result as true. So we'll be modifying the, initially we have the array to be false, 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 false. And because when we add 3 to this, we are actually getting equal to the maximum element present, so we are modifying it as true. All right, that is where we have written the if condition. If not, will not change anything, that will remain false. So coming to the fourth candidate case, when we add 3 to it, it will be 4, and the maximum element will not change, right? Maximum element is 5, so it's not crossing 5. So we'll not change it. We'll put it as false itself. So we'll not modify it. So that is the reason only one if condition, and that is if it crosses the or crosses or equal to the maximum element that is present. So and then finally return result. And I'm again mentioning it, this might not be the most optimal solution, but we are making sure we are using the STL that we have discussed so far. That is the main reason. This can be done maybe in several other ways also, but I'm just here to show you the perfect use of the STL that we have learned so far in terms of problems. So let us run this code and see if it's working. uh, okay, extra candidates we have C in this the given thing. So this is how you need to carefully check. So in the extra candidates that has been given to us in kids with candidates function, we have C to be in caps, right? So we need to make sure we are even putting it. So extra candidates, that should not be missed. So it's case sensitive, and I think it must run successfully right now. Yeah, so we have got this to be accepted. If it's accepted, that means the code is perfect. So but that is only confined to the cases that we have taken. This is case 1, this is case 2, this is case 3. And let us now try to submit and check if it's working on all the test cases that are there. So yeah, it worked on all the test cases. So 59.87, leave about all these things, just make see like whether it's working or not. All right, so our code has successfully worked and it has passed all the test cases, and this is the final result. So I hope you got enough clarity on how to use this STL, like max element and all this. So we are done with the first problem. So let me take this and come to the second problem. Let us now go to second problem. Copy link and put it over here. So this is the second problem, and I'll be sharing this slide, so I'll not be erasing any of this stuff. So I'll be I'll just go to the lower part of this. Yeah, so richest customer wealth. So this is the second question. So you're given an m cross n integer grid accounts, where account of I comma j, I of j. Okay, accounts of I of j is the amount of money that ith customer has in it in the jth bank. Return the wealth that the richest customer has. So before that, I would like to introduce you people to 2D vectors. Like 2D vectors is a vectors of vectors. All right. So 2D vectors is a vectors of vectors. Is a vector of vectors. All right. So how do I store this? Let us assume like this is a straight vertical vector. Like this is one vector. This is one vector. This is one vector. This is one vector, and above it let us have another vector. All right, so this is a vector. So push all these vectors into this vertically. All right, so vertically. So what would this result into? So this would result in some in this manner, right? So without spaces I'm doing it. All right. So and then you can just draw this horizontally. So what I'm actually trying to do, this is basically like each box. Okay, so let us assume this is one box, this is one box, this is one box, this is one box in the vector. Like this is one vector. This is one vector, and we have four boxes in it. In each box we are storing another vector. All right, so in each box we are storing another vector. So this is nothing but vectors of vector. So we are storing one vector in each of the box of the vector. So that is simple. That is how you do it. So what is he saying? So let us go to the problem and check. So you're given m cross n integer grid. So this is how it would result in, right? So where the ith customer has in the jth bank the amount of money. So let us follow the same terminology that we have discussed. Like, let us assume these are the people. Okay, first person, second person, third person, fourth person, fifth person. All right, so each of them has j banks. So let us assume these are the set of j banks that first person have. These are the second like set of banks that second person have, set of banks that third person have, set of banks that fourth person have, set of banks that fifth person have. Okay, right. So first, second, third, fourth, fifth. All right. So these are the set of bank accounts that each and every one of them have. So let us just combine them. All right. Let us just combine them. Let us first combine them. So how would that look like? So it would look like, let me use a different thing right now. So yeah, that works well. So if I just draw this in this fashion, so what can I say is, so the total five people, and each of them, let us assume they have five accounts. All right, so each person have five accounts, and there are total of five persons. So this represents, okay, this certain column represents the zeroth person, or maybe you can say like the first person first bank account. All right, first person first bank account. This is first person second bank account. All right, this is first person third bank account. So this is fourth bank account, this is fifth account. Like, this is for the very first person. All right, this is for the first person. All right, this is for the first person. This row indicates for the second person. So this is second person's first bank account, this is second person's second bank account, this is second person's third bank account, this is second person's fourth bank account, this is second person's fifth bank account. So similarly it goes down here. So this is the fifth person stuff. So fifth person's first bank account, second bank account, third bank account, fourth bank account, fifth bank account. This is how a vector is stored. All right, so I've even given that in the STL sheet, I guess. I'm not sure. So how do you actually go through the 2D vectors and all? If not, I'll be again mentioning it, putting it in the group, the article. So this is how it is, like 2D vector. So let us solve it. Now before that, let us understand the question. So return the wealth that the richest customer has. So a customer wealth is the amount of money they have in all the bank accounts. The richest customer is the customer that has maximum wealth. So what does he mean? Like the first person, let us assume he has X amount of money in his bank account. All the bank accounts combined. Second person has Y, third person has Z, fourth person has A, fifth person has B. All right, so combine all the bank accounts combined, he has X amount of money, Y amount of money, Z amount of money, A amount of money, B amount of money. So return that customer who has large like customer's wealth is what is asking. So maximum of X, Y, Z, A, B. So you need to return the value that is maximum of all these five. So that is the question, basic question. So let us see how do we solve it. All right, so yeah, so before that we'll take the size. So we'll go to the next page. Yeah, next page. So int n equals to accounts dot size, and m equals to accounts of 0 dot size. So what do I mean by this? So when we have a 5 like this 5 by 5 vector, 5 by 5 matrix, sorry, 5 by 5 matrix. So n gives accounts dot size. Accounts dot size in the sense the rows, okay, the number of rows. And accounts of 0 dot size means each row, like each box has how many vectors in it. Like each row has how many vectors in it. So we have 5 bank accounts to each and every person. Like in our example, we have taken m cross m to be 5 cross 5. So there are 5 persons and 5 bank accounts for each of them. All right, so for each person, how many bank accounts are there? 5 bank accounts. So that denotes the columns. All right, so if it would have been 5 by 6, then we would have add an extra, sorry, not here, if we have had, like, if each person had six bank accounts, then we would have had another bank account here. All right, so six bank accounts. So this is first person's, this is second, this is third, this is fourth, this is fifth. So first bank account, second bank account, third bank account, fourth bank account, fifth bank account, sixth bank account. All right, so bank accounts are denoted by the column, like of zero, accounts of zero denotes another vector, that is a bank vector. Okay, each and every box denotes one vector, and that is a bank vector. All right, that is the person's bank list, like that is a vector of banks that the particular person has, bank accounts that the particular person has. Same is the case with second, third, fourth, and fifth. I hope you got it. So n is equal to account size, that gives the rows, and accounts of zero dot size, that gives the number of columns. So let us now iterate through each and everything. So for int I equal to 0, I less than n, I plus plus. Before that, let us we are returning the maximum wealth possible. So let us store that answer to be int min. So what do you mean by int min? So many of tutors don't discuss this, and these are very very important. So int min in the sense, the least value possible in the range of integers. I don't remember it. I would advise you people to Google it. All right. So int min is the least possible value that is possible in the range of integers. For example, the range of integers that int can take is x to y. So that would be x. This is int. All right. Int min. There's some certain value to it. I don't know. Like you can even Google it if you want. So int min value. Okay, in min value. So we see that to be minus 2147483466647 minus 1. All right, so this is the int min value. So you that is the minimum value possible that would be stored in answer. So we are trying to get the maximum at each and every step, right? So that is the reason we are starting from the minimum possible value, and then we are stepping up. So as we find the greatest value, we'll step up and update our answer. So answer equals to maximum of so answer and accumulate of accounts of I dot begin, accounts of I dot end 0. So what did I write here? So what was the STL that I was using now? Dot accumulate. Okay, dot accumulate. So dot accumulate of begin, end, and 0. So what do we mean by this? Because each and every row is a vector, right? Each and every row is a vector. So this is a whole vector, 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 and this is a whole vector. So we are adding the values in all those vectors, because accounts of 0 is the first person, and this bank account, 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 this bank account has some value, and we are adding all those things. All right, we are adding all those things, and that is the reason we have used accumulate. So this function adds up all the values. Okay, adds up all the values. So this function takes from beginning, like beginning is the address that you're giving, and till that before end it will go, till before end it will go, and it will add all the values to 0. Okay, so to the part, to the point you mentioned, like I mentioned here 0. So to 0 it will start adding all the elements that it encounters. So accounts of I dot begin, accounts of I dot end. Let us assume we have like 4,000 here, 4k, 3k, 1k, 17k, 18k, 19k. All right. So first accumulation begins from here. So it will add 0 to 4k, and then 3k, and then 1k, and then 17k, and then 18k. I guess I'm not sure what I have written. So all right, so 17 25 43k, and then 19k, I guess. Yeah, so 19k. So total value is 62,000 combined, all the bank accounts that he has combined. So that would be the answer at this. So answer would be maximum of answer and this, and again it will go to the next row. All right, now the answer is 62k, answer is 62,000. So if in the second bank person, if he has much more than 62,000, answer will be updated accordingly. If not, it will stay 62,000 itself. And now after this we'll just return answer. That's it. So we have done this, all this using a very short code, some might be using very long code, and that would be much more efficient. But we are trying to make sure we are learning the STL that we have learned so far. All right, we are learning it by using it in the code. So now let us try to run this code on the test cases, sample test cases. uh, Run, and let us see the result. So yeah, it passed on the sample test cases, case 1, case 2, case 3. Now let us solve it, like let us run it on the rest of the cases as well. And yeah, we have solved it like successfully, and we have got it right. So that is the reason we have got the end result. And I hope you people did not face any trouble in understanding 2D vectors and accumulate. So especially 2D vectors, if you people had faced any trouble, so I would recommend you people to go through the documents, go through the articles that are there, go through GFG articles and some YouTube videos. I do not say I'm the perfect person to explain all these concepts, but I'm trying my level best to put it as simple as possible. There are some videos in the YouTube where people use the animations, people use some sort of graphics to explain what are 2D vectors, what do they actually mean, and all those stuff. Those are very, very interesting and would give much more better clarity to you people in understanding what is a 2D vector mean. So it's just not about 2D vectors. Later on, you might be even seeing 3D vector and all those stuff. And if you're not, in a position of understanding these things, then it would be very, very trouble for you. So I would recommend you people to go through some YouTube videos or documents and understand the things that are there. And I don't feel you people might have faced any trouble in understanding accumulate is a very, very easy STL. And it basically it's basically useful when you're trying to add the elements that are there in some sort of data structure, and especially vectors, and pushing all of them to one beginning. Like here we are using 0, the beginning point, and then we are adding up all the elements to it. And like, for doing this you might minimum require 4 to 5 lines of code. So instead of that, accumulate is just a single liner, one liner stuff. It just so it just adds up all the elements that are there in that particular vector. So that is how accumulate is very, very useful in terms of writing the code, and gives you a better output. Like instead of writing 4 to 5 lines of code, you can just put it in a single line. So going to the next question, I've even copy pasted the third question, maximum number of words found in a sentence. So what does that question say? Like, a sentence is a list of words that are separated by a single space with no leading or trailing spaces. You're given an array of string sentences where each sentence is of I represents a single sentence. Return the maximum number of words that appear in a single sentence. So basically, what they're saying is, so let us take this example sentences. First sentence is Alice and Bob love lead code. So what is the sentence? Alice and Bob love lead code. All right, love lead code. So there are total number of words are 5. There are 5 words. And second sentences, I think so too. I think so too. There are 4 words in it. And third sentences, this is great, thanks very much. This is great, thanks very much. Okay, in this sentence we have 6 words. So the output is 6. So basically there are many sentences given, and you need to figure out the maximum number of words that are there in any sentence. So I hope you understood the question. Let us go through the solution now. So first, let us take int answer to be int minimum. So that basic same convention that we have used in the previous problem. So take from the start from the minimum possible value and then keep updating. All right. So for int I equal to 0, I less than sentences dot size I plus plus. If count words of sentences of I greater than or equal to answers. So count words of sentences of I. Sentences of I is the particular sentence at the ith index, and count words is the function. So what is the function returning? It is returning some integer, and that integer is nothing but the number of words in that string, particular string. So what is the function doing? It is first calling string stream s of str. So what does that do? String stream s. So the name of the string stream is s, and it is taking the function, the parameter as str. What is the str? That string that we are passing. So what does this do is, if there are, so let us assume this is the string that we are passing. So it bifurcates, like it divides the spaces, like it omits the spaces, and it stores words in it. Like this string stream will have the set of words Alice and Bob, love, lead code. It will store all this stream of words. Okay, this stream of words in it. So that is the reason string stream. And string word, let us assume there is let us assume a string word, and in count is equal to 0. So while s this greater than, so what does this mean is you are reading from yes. Okay, so in the string stream you have five words, all right, five words there are there, and all of them are strings. Like that means there are five strings. So you're denoting each string with word. All right, you're denoting each string with word, and you're reading each and every word present in that string. That stream name is S. That is the reason we have denoted it as S. And this greater than means we are reading from that S. What are we reading? Word. We are reading each word. So how many words we'll be getting? That many count will be, that many times will be increasing the count. So when I get the first word, that is Alice, I increase my count to be by 1. So count would be 1 now. When I get and, I get count to be 2. When I get Bob, I get count to be 3. When I get love, I increase my count to be again to by 1, so it will be 4. When I get lead code, I increase my count to be count by 1, it will be 5. Now the stream is over, so we'll be ending up coming out of this while loop, and we'll be returning the count, that is 5. So this count words of sentences of 5 will be returning 5, and because that is greater than or equal to the answer that we have, answer right now we have is int min. So we'll be updating count if that is greater, because 5 is greater than or equal to int min, we'll be updating our answer with that. So each and every sentence we'll check, each and every string that is there in the sentences we'll check, and count the number of words in each of them, and update the answer with the maximum value. So this is how you do it. String stream is the STL that we are using. That is the reason I've used this problem as a source to explain you this, STL. So let us run this code now. So it worked fine. It worked with test cases, sample test cases. Now let us submit it and check whether it's working on the remaining test cases as well or not. So yeah, it worked. That is the reason we have got a result at the end. So I hope you people got a glimpse of what do we mean by string stream STL. Now let us go to the next problem. Let us first tick it and go to the next problem. So this is the final problem we'll be looking in this video. So I would not want the video to be more than 1 hour. I wanted to confine below 1 hour. Like I want the duration between 1 hour. Like I've got the feedback from you people. So the second part where we'll be discussing the other few questions that are left. So the stack, priority queue, unordered set, and multi-set map, and then unordered map, multi-set. Maybe 8 questions are there, I guess. Yeah, no, more than eight, six, seven, eight. Yeah, eight, maybe 8 questions are left. So we'll be discussing it in the next part of the video. So for this video, let's confine to these things. I'll even extend the deadline. Not to worry for the assignment stuff. So like I've given it 1 week, so I'll be putting it maybe 10, 12 days, not to worry. So this will be the last problem. I'm trying to my level best to minimize the duration, but it's not happening because I wanted to make sure I explain everything in great detail. So that is the reason it's you know uh, it's taking more time. I hope you people will understand that. So what does this question say? Given a string s, check if it can be constructed by taking a substring of it and appending multiple copies of the substring together. So let us assume there is a given string. In the example one, we have s to be a b a b. All right, and now it is the substring a b twice. So what does the question say? Check if it can be constructed by taking a substring of it. So if I consider the substring of it, so that would be a b, and appending multiple copies of the substring together, can the original string be formed? So if I just add AB to AB, I would get AB, and I'm getting the original string, right? So that is what the question is actually asking. Let us take the third example. It would be much more clear. ABC, 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 ABC. All right. So if I take the substring AB and if I add multiple times to it AB, 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 I wouldn't get this string, right? But if I take the substring ABC, if I append ABC to it again to itself, again ABC, again ABC, I would get the original string. Yes, this is this. So that is the main question. So are you able to get the same original string after appending the substring that you have taken multiple times to itself? All right. So that is the question. So let us see what would our approach be. So first, initially consider find the length. So int n is equal to s dot length. So if n equal to 1, so we'll be returning false. Why is it so? Like if I have only one character, let the string s be z. So I cannot take any substring and append multiple times to itself. If I take z to be the substring of it, and if I add z to it, I would get zz, but it's not main string, right? So we cannot form. So that is the reason we are returning false. And now we are maintaining two strings, temp and comp. So for int I equal to 0, I less than n minus 1, I plus plus. So we are moving till the end position of the string. Let us take the example as this: a b c d, a b c d. All right. So this is the s that I'm taking now. So I'm moving from this iterator till n minus 1, till this iterator. So first string temp, I'll be adding this element. So temp would be a, and now for in j equal to 0, j less than n by I plus 1. So j less than, what is n here? N in this case is 8, right? And n j is less than 8 by I plus 1. What, where am I actually at? I equal to 0. So I plus 1 would be 1. So j less than 8 in the sense j equal to 0, 1, 2, 3, 4, 5, 6, 7. All right. So from 0, from this position, 1, 2, 3, 4, 5, 6, 7. All right, this is the position. So j less than n by I plus 1, n by 8, 8 by I plus 1, that is done. And j plus plus, I'm appending this whole stuff. I'm appending temp come dot append of temp dot begin, temp dot end. What is my temp? Temp is a, right? So come dot append is your, it's less like concatenation. So you're trying to put this temp into the comp. So what is your comp? Comp is the initial empty string, right? This is the empty string, you can see. So now for this many times you're putting it a. So when, if you put 8 this many times, like how many times? 7 times. So you get a. So if, and then the next step we are checking if comp that compare. So compare in the sense you're comparing the string s that it's been given to you, this one, to the string that you have finally got. This is the comp now, right? So you're comparing both of this. If you get false, that means that is not the right answer, right? If you're getting true, then it's the right answer. So that is the reason here. If comp, so comp dot compare of yes, this is the STL that we are using, right? This is the STL that we are using. This gives 0 if both are equal. All right. This gives 1 if both are not equal. So that is the reason complement of 0. What does this mean? This is complement. So complement of 0 means true. That is 1. So 1 means true. So if this is what happening, then return true. Else again go to the next iteration. So here we are comparing this with the S. So it is a false because those both are not equal. So if they're not equal, you'll be getting 1. So complement of it would be 0. If 0, then doesn't mean that if loop is actually very satisfied. So that is the reason we'll not go into that loop. So comp is equal to again empty string. We are again putting it as empty string. Now add temp plus equal to s of I. Now I equal to 0 is over. Now I equal to 1. Now add s of 1. So initially our temp is empty string, right? After that, after first iteration, we have got temp to be a, and now after now we'll be getting temp to be ab, right? Because now we have added s of I. S of I is equal to s of 1, which is equal to b. So you can see here, this is what we have added. Now if we how many times we can add this? It's just n divided by I plus 1. And what is n? 8 divided by what is I? 1 plus 1, 2, 4 times. So if you add 4 times, why am I doing this? N by I plus 1. So you shouldn't cross the string original length. So n by I plus 1 times you have already considered. So I plus 1, see, I plus 1 is the index that you like ith index that you are there right now. So ith index means how many elements you have taken. So if you are at the 0th index, you have taken one element. If you are at the first index, you would have taken two elements. So that is the reason when you are at I equal to 1, you have considered two elements already. So how many still are left? 8 by 2, which is equal to 4. So till 4 you need to keep adding, so that you will be getting 4 sets of 2 element, 4 set of 2 elements, that is 4 into 2 equal to 8, the original string length. So that is the logic here. I hope you are getting it. So when you add b to it, ab, now append ab to come for 4 times. So starting from j equal to 0 to 4, that is 0, 1, 2, 3. So total 4 times. So if you add temp to come, you get ab, 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 ab. And this is also not equal to abcd, abcd, right? This is also not equal to abc. So that is the reason again we'll not be going into this f loop, and we'll be again having com to be an empty string. Again you do it for j equal to this time 2. So when you do j equal to 2, 8 by 2 plus 1, that is equal to 8 by 3, that is equal to 2. So from j equal to 0, 1, 2, you append 3 times. What do you append? Now your temp is abc, right? Abc. Now when you append 3 times, so am I doing it right? Yeah, 3 to 6. So this is how it will be stored: abc, abc, abc. So this is also not equal to temp, like yes. So again you'll not be going into your for loop. Now you go to j equal to 3. Now your j limit would be 8 by 3 plus 1, which is equal to 2, right? So j equal to 0, 1, 2. I hope I'm missing something. uh, all right, 8 by 2 plus 1. So when we are okay, I equal to, this is when I equal to 2. So this happens 8 by 2 plus 1, 8 by 3. So that is 2. And when I equal to like when I equal to 3, so this is I equal to 2, this is I equal to 3. 8 by 3 plus 1, 4. So that is 2. So you'll be starting from j equal to 0 and 1. All right. Okay, so this is less than 2, like this is less than 2, so you cannot consider this. 2 times you'll be appending. So abc is what you'll be getting. So that is not perfect. That is not like that is not equal to s. Now when you have I to be 3, you'll be dividing 8 by 3 plus 1, that is 2. So j equal to 0 and 1, that's it. J should be less than the value that you'll be getting here. So j less than 2, j equal to 0 comma 1. And now your temp is abcd. So now when you're trying to append this for twice in comp, you get abcd, abcd, and this is exactly yes. So we'll be going into this loop and we'll be returning to. So that is how you do it. So for each and every like you're taking the maximum possible substring, you're doing appending multiple times of the same substring to a comp string, and you're comparing the final string to the string that has been given to you. So now let us try to run this solution and check if it is working successfully or not. And yeah, it worked. Let us submit it now. Yeah, and it worked successfully. So we are able to work like our code has been successfully executed, and you work for this. So this is how you'll be using append, compare, and all this stuff. I hope you got some enough clarity about the STL that we are discussing. And there's another method to it that I'm leaving it as a task to you. I have even mentioned the STL. So you can use string.find and string.npos. So semicolon npos, like this is not semicolon, sorry, double colon. So what does that npos means? That is the end of the string. So try figuring out how can we use these two. All right, that I'm leaving as a task to you. So how can we use find and string npos and to solve this question. And if you are not able to leave, don't worry, I'll be discussing in the next video. So in the next video, so in the next video we'll be covering the problems like this one problem, second, third, and fourth, fifth, sixth, seventh, and eighth, ninth. So there are total 9 problems that are there to cover. So even I'm uploading this document, already uploaded this document, so you people can actually have a look at these questions and try figuring it on your own. Anyways, after 2 3 days I'll be uploading the solutions of these questions. All right, so this is all for the very first part of STL problems. I hope you people liked it. And after uploading the second part, I'll be putting a feedback form once again. So try filling it out, and even the deadline for the assignment would be postponed, maybe 2 3 or 4 days after. So right now the deadline has been kept to 10 June, so I'll be keeping it as 14th or 15th June. It's not a big problem. So I hope you people actually enjoyed this session. So this is all for it. Thank you for watching.